Now that we've been talking about radicals, we're going to start talking about operations between radical expressions. It's going to be very similar to operations that we've looked at between expressions involving variables and between expressions involving complex or imaginary number parts, the I. So in order to have like radicals, they have to have the exact same radical part, which means same index, same number and or variable underneath. So for example, the cube root of x is a like radical with the cube root of x. The square root of 2 is a like radical with the square root of 2. Some things that are not like radicals would be things like the cube root of y and the square root of y, or the square root of 2 and the square root of 3. Those are not like radicals. Same index, same number underneath. Same index, same variable underneath. So whenever we add or subtract, all we do is combine like variables and we simplify first if we can, meaning if you have the square root of 16, we would change that to 4. If you have the square root of 8, we would pull out a square root of 4 and reduce that down to 2 first. When we add or subtract, remember, distributing a plus sign does not change anything. So for example, if I look at this first one, I see that it is an addition problem. So I look here, there is nothing to distribute into these parentheses, so they're just going to go away. I look here, if I try to distribute a plus times a plus is still plus, a plus times a negative is still negative, so it's not going to change anything. So I'm just going to keep this or rewrite this as 2 square root of 5 minus 4 cube root of 5 plus 6 cube root of 5 minus 8 square root of 5. Sorry, this cube is kind of hard to read. From here, I combine my like radicals. So same index, same variable or number underneath. So I see that these are both square roots and they're both square roots of 5. So if I put them together, remembering the sign belongs to the number, 2 and negative 8 is negative 6 square root of 5. Negative 4 and positive 6 is positive 2 cube root of 5. Since the square root of 5 and the cube root of 5 are not like terms, there's nothing else I can do. That's my final answer in simplest form. Looking at example 2, same concept except for now I'm subtracting. So I see this, so I know it's a subtraction problem. So I first look at this set and I see there is nothing to distribute, so I'm going to just drop those parentheses away. Here, however, I can distribute the minus because even though distributing a plus didn't change anything, since a positive times a positive is still positive and a positive times a negative is still negative, a negative times a positive becomes negative, and a negative times a negative becomes positive. So that back set is going to change, giving me 2. Because I didn't leave myself a lot of room, I'm going to do this in one step. I see square root of 5 is not in simplest form. I know that 75 can be divided by the perfect square of 25. So I'm going to break this at the same time into the square root of 25 and the square root of 3. Minus square root of 30 doesn't have any perfect squares, so I'll leave it. Distributing the minus to the square root of 27, I get minus square root of 27, which is the same thing as square root of 9 and square root of 3. Minus times minus 20 becomes a plus, and then square root of 20 is the same thing as square root of 4, square root of 5. Again, pulling out those perfect squares. Please make sure if you have questions on how that I got this, you talk to me in class because I'm kind of making an assumption that we all know how to do that by now. So then this gives me, this is going to give me 5, so 2 times the square root of 25, or 2 times 5 is 10, square root of 3, minus square root of 30, minus 3 square root of 3, plus 2 square root of 5. From here, I notice that I have a couple like terms, 10 square root of 3 and minus 3 square root of 3, giving me 7 square root of 3, minus square root of 30, plus 2 square root of 5 for my final answer because I have no other like radicals. Looking at one final example with adding and subtracting, notice that in example 3, I don't have any parentheses, so I don't have to worry about doing any kind of distributing or whether or not I can drop parentheses. I do have to worry about simplifying my radicals though. 20 has a perfect square of 4, so I'm going to rewrite this as 3 square root of 4 square root of 5 minus 45, which is square root of 9 square root of 5, 80, which is square root of 16 square root of 5. So 3 times the square root of 4 is 3 times 2, which becomes 6 square root of 5, minus 3 square root of 5 plus 4 times square root of 16 is 4 times 4, which is 16 square root of 5. So since these are all like terms, they all have the same radical part, I add or subtract. 6 minus 3. 6 minus 3 gives me 3, plus 16 gives me 19 square roots of 5. And there's my final answer. That's adding and subtracting. So distribute a minus sign, drop parentheses for a plus sign, simplify radicals if you can, combine like terms. Moving on to multiplying. When we multiply with radicals, we want to distribute. Some people like to use FOIL, a way to remember where to distribute and which ones to distribute. If I look at my first one, 3 minus the square root of 2 times 5 plus the square root of 2. First times first, or 3 times 5, and outside times outside, or 3 times square root of 2. 3 times 5 is 15. With multiplying, it's not a big deal if they're like radicals or if they're one's under a radical or one's not, because we can just write things next to each other. So 3 times the square root of 2 becomes a positive 3 square root of 2. And then square root of 2 times 5 becomes minus, because the sign belongs to the square root of 2, 5 square root of 2. And negative square root of 2 times positive square root of 2, well, negative times positive is negative. Square root of 2 times square root of 2 I know is square root of 4. Some of us might just write that as 2 right away. That's totally fine. Simplifying and combining some like terms, I get 15. 3 and minus 5 is minus 2 square roots of 2. Square root of 4 is 2. Now that I've taken that out of the radical, I can combine the 15 and 2, giving me a final answer of 13 minus 2 square roots of 2. Looking at the next multiplication problem, very similar to example 1. Distribute the 4. 4 times 8 is 32. 4 times minus square root of 6 is minus 4 square root of 6. Square root of 3 minus square root of 3 times 8 is minus 8 square root of 3. And minus square root of 3 times minus square root of 6 is plus square root of 18. From here, I don't have any like terms. I can simplify the square root of 18 because it has a perfect square in it, giving me 32 minus 4. I can't simplify square root of 6. Minus 8 square root of 3 plus square root of 9 square root of 2. So taking one final step to change that square root of 9 to 3, my final answer becomes 32 minus 4 square root of 6 minus 8 square root of 3 plus 3 square root of 2. Looking at one final multiplication problem. Thing I have to remember, so it gets confusing because you've learned two different things with exponents now. You've learned that with multiplication, you can distribute. With addition and subtraction, you have to write it twice. Because I have subtraction in here, I have to write this twice. So this is going to become 4 minus the square root of 5 times 4 minus the square root of 5. Giving me, now following like I did in example 1 and example 2, 4 times 4 is 16. 4 times a minus square root of 5 is minus 4 square root of 5. Minus square root of 5 times 4 is minus 4 times the square root of 5. Minus square root of 5 times minus square root of 5. Minus times minus is plus. Square root of 5 times square root of 5 is 5, because I start with the square root of 25, which then simplifies to be 5. Giving me 16 minus 8 square root of 5 plus 5. Combining the 16 and 5, I get a final answer of 21 minus 8 square root of 5. One last thing along the same lines as multiplying. We have something called conjugates. Conjugates are two binomials that differ only by the sign in between. So for example, a plus b and a minus b would be considered conjugates. And if you remember back from when we talked about factoring, what happens when I multiply a plus b and a minus b? Well, don't I just get a squared minus b squared? Well, what if my a, so then the square root of a plus b times the square root of a minus b becomes the square root of a squared minus the square root of b squared So these are going to cancel, giving me A, minus these will cancel, giving me B. So if I look at an example with some actual numbers in it, if I have 3 plus the square root of 7 times 3 minus the square root of 7, 3 times 3 is 9. 3 times minus square root of 7 is minus 3 square root of 7. Square root of 7 times 3 is plus 3 square root of 7. Square root of 7 times minus square root of 7 is minus square root of 49, giving me 9. These combine to be 0 minus square root of 49, which is 7, or 2. Would I have gotten the same thing had I used the formula instead of doing the distributing? Well, let's see. My A would have been 3. My B would have been square root of 7. Well, isn't 3 squared minus the square root of 7 squared? 9 minus 7, which is then 2. So next thing we're going to talk about in the next video is where this might be helpful. Where might it be helpful to be able to do something or choose some operation where I can get rid of radicals?